In this video, we're going to be graphing square root functions. So looking to see what type of graph we get. Real quick, let's look at the generic square root function. In general, this is the most basic form. There can be any coefficient out here. It could be 1, which would be implied. Or it could be anything greater than that or less than that. We'll see what happens if a is positive, and compare that to what happens when a is negative. And we can complicate it farther if we add some more elements here. So much like in our other graph functions, we have an h and a k, and those represent shifts in our graph. So if we graph just the basic function, and we can then shift that graph horizontally shift it by whatever value is h. So h is our horizontal shift. If h is negative, and remember that we don't include the sign right here, we're just looking at this variable here. If that h is negative, then it would shift to the left. And if it's positive, you're going to shift to the right. So remember that if h is a negative value, you would see something like x plus a number. And that's kind of confusing. Let's try and keep that straight. That means that the h value is negative. We'll shift it to the left even though you have a positive sign in front of it. If it's got the negative sign just as it is right now, and we just substitute a number, a positive number, in for h, it looks negative, but we still shift right. K is as it is. If k is positive, then we have a vertical shift up if it's positive. And if k is negative, we have a vertical shift down. If a is positive, we are going to have a graph that opens up or goes in an upward direction. And if it's negative, our graph will be leaning downward. Alright, so let's do some examples. We'll start with our basic square root function here. Let's just graph the square root of x. So our a value in front is implied that it's a 1. So a is positive. We should have a graph that is going upwards in some fashion. Anytime you don't know the patterns for graphs, an XY table will always let you graph the function, come up with inputs, and plot their outputs. So we can start with 0. If I plug in 0 here, the square root of 0 is 0. So there's a point on our graph, 0, 0. If I plug in 1, the square root of 1 is 1. So 1, 1. And again, coming up with values that make this really easy to solve is always the best. I don't want to use 2 because the square root of 2 is a decimal value, and that's a little trickier to graph, so I'm going to want to use something that is a perfect square. So 4. If I input 4, square root of 4 is 2. So at 4, 2, another point on our graph. And I'm going to come up with one more here. If I input 9, another perfect square, I get 3 as the square root. So at 9, 3. So this is our general square root graph. It has an endpoint, and then it goes in a slight arc, either upwards if a is positive, we're going to find out if a is negative, it's going to kind of arc downward here. So this is it. This is a square root function graph. One other thing we could talk about is domains and ranges. So domain possible values that are on the x-axis. Well, as you can see, this endpoint is there because we're talking about real inputs and real outputs. So we're not dealing with an imaginary plane here or imaginary values. So we don't want to be taking the square root of negative numbers. So we can't go any more negative in our inputs than right here. So 0 is an endpoint, and we don't go farther left on the x-axis. So the possible domain or the possible x values are anything greater than 0. But it could also be equal to 0. It is 0 right here. So anything greater than or equal to 0 are possible domains of this graph. Possible range values, that would be our possible y values here. And again, we're not dipping any lower than 0 in this graph. And we're only increasing in positive y values. So any y value that's greater than or equal to 0 is a possible range of this graph. Alright, let's compare this. Let's see what happens when we do a shift here. Let's compare this to a different function here, slightly different function. Let's do x plus 1 under the radical, and we'll subtract 3 at the end there. So our h value, remember, is negative 1. H is negative 1. That gives us that plus there. And then k is negative 3. So we should be shifting this graph to the left. Each point should go to the left 1 spot and down 3 spots. Let's see if our theory is correct here. So this point should get shifted left 1 and down 3. So let's see what happens if we have an input of negative 1. Well, negative 1 plus 1 is 0. Square root of 0 is 0. And negative 3 is our output. So negative 1, negative 3, well, that is our point. Also, one trick that you might be able to use anytime you have more than just that basic square root function, if we have an h and a k value here, anything that makes the numbers under the radical equal 0, so whatever input makes all of this equal 0, is going to give you the output of k. And so that will always be your endpoint. So because negative 1 made this 0, our output was negative 3, that is our endpoint, and we will only be going farther right from that point. Let's do another shift here. So this point right here should get shifted left 1 and down 3. 1, 2, 3. Let's see if that's true. If we input 0, we should get an output of negative 2. Well, 0 plus 1 is 1, square root of 1 is 1, and 1 minus 3 is negative 2. So it works out. Alright, let's keep shifting this point now. Left 1, down 3. 1, 2, 3. An input of 3 should give me an output of negative 1. Let's check it. 3 plus 1 is 4. Square root of 4 is 2. 2 minus 3 is negative 1. One last one. Let's shift this to the left and down 3. 1, 2, 3. So if I have an input of 8, I should get an output of 0. 8 plus 1 is 9. Square root of 9 is 3, and 3 minus 3 is, in fact, 0. So our shifts held true. This is our original y equals the square root of x graph shifted to the left 1 and down 3. Now the possible ranges and domains of this graph would be x could be negative 1 and anything greater or equal to that. And the domain would be any possible outputs starting at negative 3 and increasing more positive from there. So anything greater than or equal to -3. Alright, let's do another example here. Let's do a negative a value and see what happens with our graph here. So we'll keep it simple to start with. If we plug in 0, we get the square root of 0. 0 times -3 is 0. So 0, 0 is a point on our graph. Let's try 1. Square root of 1 is 1 times -3 is -3. So 1, -3. So now we're going downwards because a is negative. Let's try out 4. Square root of 4 is 2. 2 times -3 is -6. So 4, -6. And one last one, 9. Square root of 9 is 3. 3 times -3 is -9. So 9, -9. And we can see our graph going in the negative direction because a is negative. Alright, let's do a shift here. Let's add something else to our function. And see if the shift works, if it holds true here. Let's say x minus 2 plus 1. So our h value is just positive 2, so we should be shifting to the right, and our k value is 1, so we should be shifting up 1. So this point at 0, 0 gets shifted to the right 2 and up 1. Let's see if that holds true. An input of 2, that would make this 0. If that's 0, it's an endpoint here, and our output should be whatever k is, so 1, and we did get 2, 1. This point right here shifted to the right 2 spots and up 1. So an input of 3 should have an output of -2. Let's see. 3 minus 2 is 1. Square root of 1 is 1. 1 times -3 is -3, and -3 plus 1 is -2. So it's true. This point right here shifted to the right twice and up 1. An input of 6 should give me an output of -5. 6 minus 2 is 4. Square root of 4 is 2. 2 times -3 is -6, and -6 plus 1 is -5. One more. Shift to the right 2. We're off our graph and up 1. So I think that's an input of 11. Should get an output of -8. 11 minus 2 is 9. The square root of 9 is 3. 3 times -3 is -9. -9 plus 1 is -8. So there's our shifted graph. Alright, so there's a good introduction to graphing square root functions. You'll always get a shape like this if a is negative. It will go in the positive direction if a is positive. You can always plot the simplified graph and then do your shift moves, or you can just plot an XY table and get your graph that way as well. So good luck practicing graphing square root functions.